Now, this is a typical ICT 1900 computer installation. It's capable of performing a variety of different tasks, many of them simultaneously, all at high speed. It can read cards or paper tape, perform complicated sorts, print results, and calculate all at the same time, and all without human intervention.
What does control it, then?
The program. There are many different kinds, of course. Some for common jobs like inventory management or PERT, which are supplied by ICT, and to which you have only to add your own particular figures. But let's consider now only the everyday sort of program, which your staff would write for your own work.
But what exactly is a program?
A sequence of instructions which have to be fed into the computer's core store before it can start working. These instructions are memorized by the computer in machine code, the binary language in which computers work. And this one here, for instance, instructs the computer to add the number held in accumulator 4 to the number memorized in the 192nd word of core store.
Does the user of a computer have to write all these noughts and ones and remember what they stand for?
In the distant past, he would have had to. But nowadays, for a modern computer like the ICT 1900 series, programs are written in a programming language. This one here was written in Plan, the basic all-purpose programming language for the 1900 series. It's a kind of pidgin English. ADS for add to a number and store. 4, the designation of the accumulator where the number to be added is held. Hours, the description of the number to be increased.
And the computer understands terms like hours?
Yes, because Plan is a symbolic assembly language. The various items in the program can be referred to by symbolic names like hours, which are translated into memory locations by the computer itself.
How many separate instructions are there in a computer program?
Usually a few hundred. But sometimes, of course, it runs into several thousands.
Does the user have to write all these instructions himself?
Not when he's writing a program for one of the ICT 1900 series computers. In fact, he only writes comparatively few of them.
In that case, who writes the rest?
Some are macro instructions.
Macro instructions? What are they?
A macro instruction is a whole string of machine code instructions generated by the computer in response to only one of the user's instructions. Then there are subroutines, whole chunks of program to deal with standard tasks like calculating pay-as-you-earn tax deductions and the like. And housekeeping routines to cope with chores like checking files and tidying up records for printing and so on. And utility routines, which are really programs in their own right, to do jobs like copying files from paper tape to magnetic tape, or sorting records into sequence for the user's own program.
So the user doesn't have to write any of these?
No. The computer copies them all from the program library.
Do you literally mean a library?
Yes, a library full of subroutines, housekeeping routines, and utility programs, all written by ICT. Of course, the library isn't actually a lot of books, but is in a form suitable for computer reading, such as punch cards, paper tape, magnetic tape, or discs. Finally, executive. The ICT 1900 series control program is permanently in the computer's memory, supervising all the work that's going on, starting and stopping peripherals, assigning priorities, saving the programmer the trouble and time of having to write his own control routines for each program, and making sure that all programs are always executed in the most efficient fashion.
I see. So the user writes his part of the program in Plan, and...
Yes, but he doesn't have to write his program in Plan. He can get away with even less work if he writes his program in COBOL, for instance.
What's the difference?
COBOL is a high-level programming language. The user only has to write simple statements in a form very much like everyday English. For instance, add overtime to hours. In response to each statement, the computer generates 10 to 20 separate machine-coded instructions. COBOL selects the subroutines and housekeeping routines for the programmer, and executive stays in control of the program's execution.
Are there other programming languages?
Yes. There's Nickel for the smaller ICT 1900 installation. This, like COBOL, is intended for commercial applications. And for scientific applications, there are Fortran and Algol and EMA. And there are other languages for special jobs such as machine tool control.
But what happens if a commercial program contains some scientific calculations? What language do you choose?
Oh, that's easy. On an ICT 1900 series computer, one can mix languages, so that in such a case, the user simply writes the scientific calculations in, say, Fortran, and the rest perhaps in COBOL. The computer will see to it that they are put together correctly.
You keep saying the computer generates instructions. The computer puts programs together. The computer copies. How, in fact, does the computer do all this?
Well, it's simple, really. A programmer writes his part of the program, the source program, in Plan or COBOL or Fortran, or some other programming language, onto a coding sheet. From this, the program is punched onto cards. Each character, letter or numeral, written by the programmer, is converted into a set of holes. Having been punched and verified to eliminate the possibility of errors, they are ready to be fed into the computer. Of course, one doesn't have to use cards. The program can be punched onto paper tape. The cards are read into the computer at a rate of up to 900 cards a minute, which is over 70,000 characters a minute. As each card is read, the instruction punched into it is stored away in the computer's memory. The compiler now begins a translation process.
The compiler?
The dictionary cum grammar used by a computer to translate the source program into its own language. The computer takes each instruction from the source program in turn and looks up its meaning in the compiler. Some just have to be translated into machine code. Others generate a whole string of machine-coded instructions.
Oh, yes, I remember. Macro instructions.
Others, again, are calls, asking for a subroutine or housekeeping routine. Each time the compiler comes across one of these calls, it makes a note of it. This process is repeated till the whole source program has been dealt with, and the first draft of the translation, the semi-compiled program, has been completed.
Why call it semi-compiled?
Because this is only half the story. The compiler now calls in another special program, the consolidator, which turns the semi-compiled draft into the final or object program.
And what about these calls you mentioned earlier?
They're dealt with now. The program library is put online or made available to the computer. The consolidator then searches through the program library, finding the required subroutines for each call, which it copies from the program library into the user program. Or, of course, housekeeping routines, which are also copied. It goes on copying whole large chunks of program from the program library into the user program till all the calls have been satisfied. The checked and complete object program is now ready to be run on the computer, under the control of executive. When the actual job is run on the computer, any utility programs needed, for example to sort the data into the right order, will be called into the computer store from the library and carried out. The rest of the job will be done by the object program. A lot of instructions, but take away the utility program, take away the housekeeping routines, take away the subroutines, which were merely copied into the program. Take away all the instructions which were generated by the compiler itself. Take away executive, which is permanently in the computer. And this is all the user himself has to write. A description of his own problem in simple terms, familiar both to himself and to the computer. The rest of the work was done by ICT and by the 1900 series.